Okay. All right, as I mentioned yesterday, you can go to view and you can go to speaker. And Kak Hana have spotlighted me so you can see my face. But if you want to look at everyone's face, you can go to gallery. After this, Hana, I will need to ask your help to share a screen for the questions from the back of chapter 1, and we can discuss on some exercises. Okay? All right. Okay, so I will continue with what I left yesterday about mathematical induction, and then we will do some examples. All right. So I hope, because there's one student that suggested to make it closer, dia kata dekatkan sikit whiteboard tu biar besar. So I don't use the webcam, but I use direct this laptop's camera. I think it's closer, tapi saya kena adjust so I won't be in the way. Okay, mathematical induction, yeah. Okay, so the first step, so Pn will be given, yeah. Pn will be given. Pn is a statement meaning there is a true or false that involve n, and n are natural numbers. Okay, you will be given this statement. Okay, then we have to prove Pn is true. Or n a natural number starting from 1. Okay, so step 1, prove P1 is true. Step 2, assume Pk is true. Prove Pk plus 1 is true. Step 3, you just copy. Okay. Step 3, you just copy. Since P1 is true and Pk plus 1 is true, then Pn is true for all n. So the point is, actually, it's easy in a way that you are already given the answer. This is the statement that you have to prove. Okay, if you can prove this, then you can prove the mathematical induction. Okay, you are already given the statement. Okay, now let's see. This is a very common example of mathematical induction, yeah? Okay, so first one, show by mathematical induction that for all n bigger or equal to 1, 1 plus 2 plus 3 plus n is n plus 1 over 2. Any of you know the story of this equation? Tahu tak? Ada reaction yang tak tahu tak? Ada reaction yang the opposite. Oh ni, saya tak pernah pakai reaction ni ya. That's the no. That's meaning you don't know. Yeah, Amelia, itu macam bosan aja reaction tu. The question is, Fahan, kono nak macam cool lah tu. The question is, have you heard who found this equation? Yes or no? No ya? Macam Syahira tu pun okay juga.
No.
No. Is it Ramanujan?
It's a 10-year-old boy.
Oh, it's not him. Okay.
I think it's 10-year-old or 8-year-old. Okay. I forgot the name. Alamak, lupa pula lah nama. You can search after this. Who found this? Okay, the teacher give the student to calculate this. The teacher give the student, macam dah jam 4 macam tu kan, to calculate this. So, most student or all student start counting. Plus, right? 3, 6, lama tu nak habis. And then this one student directly get the answer. Okay, very fast. So, what do the student, what did he do? He write 1 until 100. And then he write the other way around. From 100 to 1. And then he added, what do you get? The matching one. What do you get when you add? 101, 101, 101, right? 101, 101. How many 101? How many? How
100.
100 of 101.
100 of them, right? 100 of 101. But you counted twice, right? So you have to divide by 2. Okay, so this is how the boy got this n, because there are n of them, n, and then add 1, that's why you get add 1, and divide by 2. I think it's Gauss. Rasanya lah, yeah. So you can, history of mathematics is very, actually, seronok lah baca buku. There is a history of mathematics. Saya pula terlupa buat tiba-tiba nama dia. So you can count until n, and then you can write n minus 1, terbalik pula. Then you add, every single one you will get n plus 1, and there are n of them. So, but you have to divide by 2 because you do multiple double, right? So this is how actually, genius lah kan? He can think that way. Okay, but now, you can also write this, or the question can be written as show by, I put this, yeah, PMI, yeah? Principle of Mathematical Induction. This. This is the same, because when k is 1, right, 1, then this means plus, right? When k is 2, when k is 3, until k equals n. So you will get this actually when k is 1 plus 2 plus 3 until n is equal to. So don't get confused if the question is like this. This is actually very similar to this one. Okay. Okay, that's another way of asking this question. All right. So what do you have to do? Step 1. Step 1, show P1 is true. You have to show left and then right. Okay, what do you have to do? Just replace. Okay. When n is 1, so when n is 1, you just have this. because you just add one time, right? When n is 1, don't put 1 plus 1. There is no 2, there is no 3, it's just 1. When n is on left-hand side equals 1. Okay, left-hand side. This is left-hand side. Right-hand side, replace. Okay, right-hand side, 1, 1 plus 1 over 2 is cancelled, right? Which is 1. Thus, P1 is true, right? Or you can put equal. All right. The common mistake that the student does is the student put this equal this. You want to show left equal right, but you automatically put 1 equals 1 plus 1 over 2. That is wrong. Okay, you cannot put because you want to show this. You cannot just put equal in the beginning. If you want to show this is okay. Are they equal? Right? Okay. So sometimes you put like this. Okay. But this is the right way to write it. Calculate the right hand side, calculate the left hand side, right and left, they are equal. So P1 is true. Okay. This is the first step. Always plug in n equals 1. Okay, nak padam ni? Okay, you have to show your jempol ya. Okay. Shakir, since your video is on, I can see you do this, but the others I cannot see. Okay. Now, step 2. Step 2 is assume PK is true. Show PK plus 1 is true. Normally, under mathematical induction, the algebra, the one that you are doing in step 2, is quite straightforward or easy. But the hard thing is that how do you apply the assumption to get the desired part of PK plus 1? Okay, the algebra is normally quite easy. But how do you how do you formulate from the assumption to the hypothesis? This one. Okay, now for PK plus, okay, since this is true, since PK is true, 1 plus 2 plus 3 plus K equal K plus 1 over 2. Meaning you just replace n by K. Okay. Now you want to show this. Now, P of K plus 1. Okay, this is, I'm just copying. What is PK plus 1? PK plus 1, meaning replace n with K plus 1. So I will write 1 plus 2 plus 3 plus, but I want to use the assumption. And the assumption stops at K. So I will do like this. So you can see, right? This K plus 1 is from 1 until K plus 1, right? But I put this one before is K, right? And then add K plus 1 because I want to replace this with this assumption. Okay, I cannot write this equal to, I know that I have to show this is equal to K plus 1, K plus 2 over 2, but I cannot write that now because I want to show it. Okay, you cannot put is equal the answer. Then I put, okay, this part is by assumption, right? This part is by assumption this. So you just replace. And then this part, right? In the back of your mind, kertas conteng pun, you know that you had to show this is true. Ini kertas conteng ya. Meaning you had to show k plus 1, k plus 2 over 2 equal 1 this 1 plus until k plus 1. Right? I just put like this, yeah. I just want to put this. This is what you want to show. So I take the left-hand side, this. I want to show that in the back of my mind. But this one, you can see, don't multiply out, and then you have to multiply, and then you have to factor, but you see there is a common factor, right? K plus 1 here, k plus 1 here, take out k plus 1. Then what's the rest? K over 2 plus 1, right? K plus 1, factor out, k over 2 plus 1. And this one, this over 2 is k plus 2, right? Because this is 2 over 2. So this is equal, which is we have to write k plus 1, k plus 2 over 2. So you already show thus p of k plus 1 is true. Okay. Keluar pula daripada frame. Alright. So step 3. Step 3 is the easy step. Just copy paste. Step 3. Since P1 is true and PK plus 1 is true, thus PK is true, Pn is true for all n in n. Just copy the exact. Okay, it's always that. Because that is why, what does it mean by mathematical induction? P1 is true, right? And then if Pk is true, the k plus 1 is true. P1 is true, so by the second step, P2 is true. P2 is true plus 1. P3 is true. So you don't stop, right? So by step 1 and step 2, you have all are true. This is actually mathematical induction. Okay, let's try one more. Okay, all right, example 1.36. Padam. Any question? Alah, dah padam baru nak tanya. Any question before I go to the next question? Example? Any question? You can type in the chat also. Okay. Ghost tadi kena check ya. Double confirm. Okay. Show by mathematical induction that 2 to the n is bigger than n. For all n in n. Okay. Okay, the first one is step 1. Step 1. Show. Maybe we don't just keep that, right? Proof for n is 1. Okay. Okay. Now, left hand side. 2 to the n is 2 to the 1, which is 2. I write 2 ways to do it. Right hand side, nothing. It's just 1. right? 2 is bigger than 1 is true. Thus, P1 is true. However, or as long as you got the point, I don't mind. Okay, if you want to write 2 to the 1 bigger than 1, you put this, it's still okay. Because we don't know, right? We just write out and replace. Okay, then 2 bigger than 1 is true. Then you put P1 is true. That's enough. Okay. Now step 2. Step 2. Assume PK is true. I just write in the same line, yeah? Assume PK is true, that is 2 to the K is bigger than K. I think this way is much easier to see. To write out what you want to prove, assume what you want, you can assume. Proof PK plus 1 is true, that is replaced by K plus 1. I think this is the best way to see rather than not putting it, right? Put it like this. Assume PK is true, replace in here. Proof PK plus 1 is true, replace in here. And somehow you take one side, use the assumption, get to the other side. So this is how mathematical induction is. So you take the left-hand side, 2 to the K plus 1 equal. I mentioned about the basic algebra, right? So you have to know at least how to get from here and replace that. So this is 2 to the K times 2. I want it 2 to the K, right? So, okay. Now, 2 to the K is bigger than K. All right. So this 2 to the K is bigger than K, which is K times 2. I want to rewrite this as 2K. Okay. 2 to the K is bigger than K. K times 2 is 2K. How do I go from here to here? Now I already have this. I already have this, but how do I get this? But 2K is actually equals to K plus K, right? 2K is K plus K, equal, not bigger than, is equal. And our K is 1, 2, 3, right? Is bigger or equal to 1, right? So this 1K, this one is this K because I want the K. This K is bigger or equal to 1. Now I got this, right? When you see it's okay, that has equal, but this is already bigger than. So when you read from left to right, you will read 2 to the K plus 1 bigger than K plus 1. Right? Which is the right hand side. Don't forget to conclude. Many students, they get so excited that they are able to prove, then they forget to write the conclusion. Okay, so thus PK plus 1 is true. Then step 3. Since P1 is true and PK plus 1 is true, thus Pn is true for all n in n. All right. I want you to go through example 1.37 yourself. Yeah. Don't read mathematics. You can never read, but to look at the question and then try to answer without looking, right? If you got stuck, look at the solution and see why and how you got stuck and to get the solution. That is how you quote unquote read mathematics. You don't read mathematics. You try to understand. Okay, I think it's straightforward for example 1.37. Okay, let's see. Okay. All right. Example 1.38 is very similar. Example 1.38. 1 plus 2 to the n less than 3 to the n. Oh no. Sometimes this can be changed. Because if you replace n with 1, you don't get 3 less than 3, right? So you can start with 2. Okay, you can start with 2. Okay. Okay, so all right. You can try. Don't wait for my answer. You can try, write out. Yeah? Okay, so step 1. Show P1, right? P1. Pn is 1 plus 2 to the n. So P1 is, oh, no, not P1. Start with 2. P2. So sometimes when they give you a different range and domain, then you have to follow and you have to start from the domain that is given. So you have to read your question very carefully, okay? Because if you start with 1, it won't work. All right, so 1 plus 2. When you replace n with 2, what do you get? Pak dengar suara lagi lah. Somebody give some voice. What's the answer? Merah, saya tanya Wei-Jin lah. Wei-Jin, Pak. Unmute. Okay. Give me the answer.
5.
5. Okay, then we put less than
3 power 2, 9.
is true. You
Yes.
can also write like this, yeah? Okay. Because when we read, if you don't want to write this, you just write like that, but you put like this. Okay, this means you write the left-hand side, and then you put a question mark, is it true? And then you put 5 less than 9 is true. Okay, and then you write, thus P1 is true. Okay.
P2, doctor.
Yeah. All right, so now you go to step 2. Step 2. When I said okay, you automatically have to say either okay or you show me at least. At least I can see someone show it. If nobody show it, meaning I had to wait, you haven't finished, you want to write something. Okay. All right. Step 2. Okay. Assume P, K is true. That is, okay, that is, can somebody read it for me? Alia Zulkifli, boleh lah. Alia. Can you read? 1
plus 2k less than 3k.
Okay, now read the PK plus 1.
1
Just read it. 1 plus
1 plus 2k plus 1 less than 3k plus 1.
Okay. Right? Okay, so to show that this is true, you take the left-hand side, right? Take the left-hand side, 1 plus, oops, 1 plus 2 to the k plus 1 equal 1 plus 2 times 2 to the k. Okay, 1 plus 2 to the k plus 1 equal, I just have to have 2 to the k by itself. So we don't want this. So how do you do this? How do you break up to replace this and later on you get this? Any suggestion you can read for me?
Oh, Prof. Actually,
Yeah.
can you replace a 1 with 2 to the power k?
This can I replace with,
2 to the power k.
but it's less than, right?
Yes, less than.
Okay. Why? Because we want to take, to get this, to get 1 plus 2 to the k. Let's try this. Okay. Now from here to here, 1 is less than 2 to the k, because when k starts from 2, you will get 2 squared is 4. All right. And you want 2 to the k because, I don't know, you give me the answer. So because you can take out 2 to the k, what? And 1 plus this is what you give me. If you give this is less than 2 to the k, you take out 2 to the k, what's left is 1 plus 2, which is 3 times 2 to the k. But you don't get this. I want this form. I want this form. How do you get this form from here? Any other suggestions?
A 1 plus 2 to the power k plus 2 to the power k. Sorry.
1 plus 2 to the power of k. Okay. There are other possible ways, actually. Let me share the one that I have given you in the notes. Sometimes it's not easy to start from the left. So you can start from the right. Okay, you see? That's why it's quite hard. It's not like before. You can just replace and replace. I want 1 plus 2 to the k to be somewhere here. This one, I cannot get 1 plus 2 to the k. So let me erase this first, right? From here, I want to replace, but there is a 2 here. There is a 2. And you want this to be less. If you want 1 plus 2 to the k here, this is actually like this, right? But I don't want bigger, I want less. So let's try to do it from the right side. Try to go from the right to left, okay? So this one cannot work. So you take from the right hand side. Okay, so I take 3 to the k plus 1. Now, easy, right? It's just 3 to the k. So this is 3 times 3 to the k, like the one that we do before. Okay. The 3 to the k is bigger than 3 to the k is bigger than 1 plus 2 to the k. Then you can just multiply and see 3 plus 3 times 2 to the k. You want this, okay? You want this. Okay, you want this one. You want 1, right? Not 3. Okay, and this one you want k plus 1, not k. Okay, so we want a 1. 3 is bigger than 1. 3 is bigger than 1. Almost. I want this to be 2, right? I want this to be 2. So I will get k plus 1. But 3 is bigger than 2, right? Now, this is 1 plus 2 to the k plus 1. Which is this? Okay, 1 plus 2 to the k plus 1. So, thus, 3 to the k plus 1 is bigger than 1 plus 2 to the k plus 1. So, pk plus 1 is true. Okay. So, one way you cannot do this way, you go the other way. Imagine if you start from the left, like before, what do you have to do? You go from here. This is still okay. But how do you go? Okay, this is still okay, right? Just now we got to this point and then we stop, right? So how do you go and how would you know from here to go to here? Right? Suddenly this is less than this because you want to go this and you want to go here, which is actually quite hard. But the other way around is much easier. So this is the one that I share, that actually the algebra is not that hard, right? But the trick, there is a trick. You want to get to your destination and you know the answer is already here. But how do you get the answer? So actually the solution sometimes is not unique as long as you can show it. Sometimes you can go from both left and right hand side. Okay. That is the word. Okay. 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 Let me see. Okay. Tak nampak tangan yang not okay, not okay. Okay. Okay, what I want to do now is take a 2-minute break. Okay, cari air sekejap, right? After this, we'll go through the exercises. Okay, there's at least one of you mentioned to show more examples, to do exercises. Kahoot semua saya tak buat lah. That's like not suitable for the class. So quizzes I will give towards the end of the sessions. I will let you know. I give you just a short quiz, but we will go through the examples. Oh no, I mean exercises. I don't want to give you too much things to hand in. At least you understand. That's matter more to me, right? 2 minutes. 2 minutes is really a short time, yeah? Already 2 minutes. Okay, Hannah, can you share the list of exercises? Do you know if people is sharing, you can move the border, drag left and right to make the sharing smaller, to make my face bigger. And while Hannah is sharing, you see the one on the middle, right? You can actually move to make the right one or my face bigger, and then you can go to view, you can go to speaker. I think Hannah spotlight me, right? Or you can pin me on the top right at my name, or if you do side by side gallery, then you can see your friend's face. You can move, see other faces, and you can make it small or big. Okay, so this is what you do in Zoom. Okay, right. So I will put in gallery. So actually, at least I see Akmal's chair. Alia, are you cold? Okay. Tak demam ya? Alright, okay. Alia, Afika, can you unmute?
Yes.
Okay. Kita pergi soalan pertama ya, Alia. Alright. Which of the following are statements? Meaning whether there is a truth value or not. Okay, if you know the truth value, then the answer is yes. If there is no truth value, then the answer is no. All right. It is okay if you cannot answer any question, I will help. But let's learn together, yeah, Alia? Okay. 1A. Can you read and then give your answer?
Is 2 a positive number? No. Not a statement.
Not a statement because it's a question, right? Okay. If you said 2 is a positive number, it is a statement. This is a question. Okay. All right. The second one.
X squared plus x plus 1 equal to 0. Is a statement.
Why?
Dia boleh true, dia boleh false.
But you don't know what X is. You don't know what X is. So if they give you X is a natural number, X integers, right? So if you are just given this, you are not sure whether it's true or false. You cannot give the answer. If I ask you now, is it true or false? You don't know because you don't know what X is. Okay, so it is not. All right. Okay. C.
Study logic. Not.
No, because dia arahan, Dia arahan, they just ask you to do it. It's not true or false. Okay, next.
There will be snow in January. Statement.
Yes, because whether there will be snow or there will not be snow. Okay. Last one.
If stock prices fall, then I will lose money. A statement.
it will have either true or false. All right. Okay. Why suddenly exercise number 4, Hannah? Number 1 and then number 4. Please help me mark that, yeah, for I have to edit that. Okay. All right. Who want to answer this? You can raise your hand or you can unmute. Otherwise, I will call your name. I haven't called. Let's see. Emilia, Eliza.
Yes, doctor.
You don't have to turn on your video if your internet is not that good, but I would like to at least hear everyone's voice at least once this semester. Yeah, Emilia, can you give the answer to that 4? That number 4 is actually number 2. Give the negation. Okay, give the negation. Okay, before you give the negation, I want you to give me the P and the Q. I will help you to go through it, yeah? Okay. It will rain tomorrow.
P, it will rain tomorrow. Q, it will snow tomorrow.
It will rain tomorrow, or it will snow tomorrow. Really, we have to change the example. There's no snow in Malaysia, but okay, P, it will rain tomorrow. Q, it will snow tomorrow. Okay, and what is the statement? P?
P or
P
Q.
or Q. And try to negate.
Not P and not Q.
P or Q.
Not P and not Q.
Not P and not Q. Read it in the sentence.
It will not rain tomorrow and it will not snow tomorrow.
Okay. It will not rain tomorrow and it will not snow tomorrow, right? And yeah, it will not snow. Okay, sometimes the original one is okay. The negation is not logic, but we're not talking about the right sentence. We're just talking about what is the sentence of the negation. If the original one is true, the negation will be false, right? So don't worry about the logical or the grammatical in the answer, because this is just direct translation of the original one. Okay, Emilia, one more. B?
If you drive, then I will walk.
If you drive,
then I will walk.
why? Merajuk ke apa ni? If you drive, I will walk. Why you don't go with me in the car? Okay, so P.
You drive.
You drive. Q.
I walk.
I will walk.
I will walk.
So, what is the symbol? P implies Q. If, then yeah. Okay. What's the negation of this?
Not P or not Q.
Not P or Q, right?
Yes.
P implies Q is not P or Q. So we take the negation, right? The negation is equal
P
to
and not Q.
P and not Q. So can you read?
If you drive
There's no if.
and
You drive.
you drive, and I will not walk.
And I will not walk. Okay. Okay, don't worry about whether it's logic or not logic, it's just the negation. Okay, number 5. In each of the following, form the conjunction and the disjunction of P and Q. Okay. It's just straightforward, right? P or Q, I will drive my car, or I will be late, right? I will drive my car and I will be late. It's just combination. For part B, the norm is bigger than 0 or less or equal to 15. All right. So you can write for that one, for part B. For the O, there's a, this is the O, yeah? Okay, it's bigger than 0 and it's less than 15. N or O, this one is N or O? Let me just write with X. We are always easy with X. X bigger than 0 or X is less than or equal to 15. It's either one, right? Bigger than 0 or less than. The other one is X bigger than 0 and X is less than. My question is, this is the first one or the second one? Yes? No answer? When you said X is bigger or equal to 0 and, right? And less than 1. So actually, this one is this one. Right? Okay, number 6. Number 6, go up a little bit. Okay. Let me find one name. Johan, are you here? Johan?
Hello. Yes, doctor.
Okay, number 6, Johan. Determine the truth or falsity. Okay, 6A. You just said 2 is less than 3, false, or 3 is a positive integer, true. Read it like that.
2 is less than 3 or 3 is a positive integer.
Okay, true or false? True or false?
True.
True. 3 positive integer, true or false?
No. 2 is less than 3. True. 3 is positive integer. True.
True. So true or true becomes?
True.
True. This is how you do it, yeah? Okay, this is true or false. This is true or false. The second one. Johan, the second one.
2 is greater and equal 3 or
false,
3
right?
is,
False.
false, or 3 is a positive integer. True.
True. The answer is?
True.
True. All right. Okay, C.
2 is less than 3. True. Or 3 is not a positive integer. False.
Okay.
false.
True
false
or
true.
false?
True.
Because there is one true. Okay, and last one, false, false, false. Right? Okay. We're done with number 6. Number 7. Okay. Number 7. Okay, up a little bit, up a little bit. Number 7, yeah. Okay, 7, 8. 7, 8. Find the truth value of each proposition of P and R. What is that? Find the truth value of each proposition if, typo, yeah, if P and R are true, Q is false. P are true, Q false. Silap, eh? If P and R are true and Q is false. Okay, so the first one, okay, the first one is not P and Q or R. In this case, you don't have to write the whole truth table of 8 rows. They just want you to do this one case, okay? Only one case. Let me see. Okay. Siti Nur Nabiha. Siti Nur Nabiha. Okay. Are you here?
Yes, Prof.
Okay. Now, you just give the truth or false here, right? So P is true, not P is?
Not P is false.
Okay. Q is false. R is
True.
okay. So this is just false. What is false or true?
True.
True. And false and true?
False.
False. Kacang lah. Kacang skip lah. It's too easy. Go to the next question. Okay, number 8. This one, you can just do it. They want to us to find the negation of the statement 2 is even or -3 is negative. Okay, 2 is even or -3 is negative. 2 is even or -3 is negative. So the negation would be 2 is odd and -3 is positive, right? 2 is odd and -3 is not negative, sorry, positive. That's the negation. The negation of 2 is even or -3 is negative is equal to 2 is odd and okay, my question. Tadi siapa yang saya panggil tadi? Lupa pula dah. Who's the last person I called just now?
Yeah.
Siapa tu?
Nabiha.
Nabiha. Okay, Nabiha. Can I write here as positive? Not negative. Is it positive?
Yes.
Can I replace this with positive?
Can.
Cannot. Cannot. if you have this number, okay, positive will be this, right? That is positive, right? Because positive is bigger than 0. Negative is less than 0. Okay, if you say not negative is positive, then where is 0? Okay, my question is 0 positive or negative? What's your answer? 0 is not positive and not negative. Kesian kat 0. If you said not negative is positive, kesian kat 0. It's neither, yeah? So that's why if it is not positive, we say non-positive integer. You don't say if it is not positive, it's negative because 0. So that's why when we put this positive, we put like this. If negative, we put like this. If it's not here, if you want to include the rest, we would say non-positive. And if you want to say here, non-negative, right? Non-negative or not negative, it's not positive because it includes the 0. Okay, so make sure when you write the negation, the opposite of positive is not negative, but the opposite of even is odd, because a number, if it's not even, is odd. That's the opposite, right? Including 0. 0 is even. Okay. All right. Okay. All right. So I already give the answer. Go next. Okay. Now, okay. Wait. All right. Can everyone write a truth table for number 12? Right now, you have a paper, right? Write out a truth table for number 12. So we have 3, P, Q, R. Since we have 3, we have 8 rows. Okay, so 8 rows divided by 2, you have 40 for F. Okay, and then you divide again by 2. So TT, FF, TT, FF. Then TF, TF, TF. Okay, now the first one is not P. Not P. I will do not P. F, 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 T, 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 T. Not P. The next one I have not P or Q. Not P or Q. Okay, so I do this and I do this, yeah? Not P or yeah? T, T, F, F, T, 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 T. Not P or Q. Then not R. Not R. F, T, F, T, F, T, F, T. Not R. And then I have the rest, right? Not P or Q, N, not R. Not P or Q, N, yeah? So F, T, F, T. The only one that's T will be if both are T. 3T. Let me know if I make a mistake. Okay? Magic word, okay? Okay. Hannah, what happened here? Number 13.
Not sure, Prof. I will ask Shiham first.
Okay. We skip number 13 for next class, yeah? Shiham is not here today. Shiham helped me with this typing. Okay. Tiba-tiba keluar arrow turun bawah pula. Okay. Okay. This one is new, yeah? This one is new. Ada triangle pula. Dia kata, okay, let's try to write out. This is something new, yeah? So, formula baru, eh? Okay, now we have T, T, F, F, T, F, T, F. Ada triangle pula, new. Okay. This is true if either P or Q, but not both, is true. Okay, it will be true if either one, but not both, is true. So, like this, right? Okay, so this is the new rule. Is not part of our rule from before. Okay, it's true either one. Either one is true, but not both. Okay, then you have to make a truth table for this one. Okay, let's do number 15. Number 15. P and Q, and then that triangle P. Okay. So I will erase this first. I have P and Q. P and Q. So true, false, 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 right? And then the question is P and Q, triangle P. Okay, oops. Okay, so you compare this with this. We want to be true. We don't want the same, right? False. True. False. Okay, to be true, they have to be both different. Okay. Okay. No thumb. Okay. All right. Skip that. Go down. Okay. This one you can try yourself, yeah. Number 16. Okay. Wait. 16A. I will give one 16A. I am awake. P. I am awake is P, implies that I work hard. Okay, that is for 16A. All right. I dream of home only if I am awake. So R and P. So the word changes. So you have to go back and see at the notes. Sufficient and necessary, right? Sufficient is P, necessary is Q. P implies Q. So it's just playing with the Q and R and P. Not being awake, the last one. Not being awake is not P. Okay. And dreaming of home is R. Like not P and R implies Q. So this is just to rewrite in terms of symbols. Okay. Don't worry about whether the sentence is logic or not. 17. Okay. 17. State the converse of each of the following implication. It's quite easy. Converse for P implies Q. What is the converse? It's just Q implies P. Okay, so for 17A, the answer would be if I am not the Queen of England, then 2 plus 2 equals 4. Okay, that is the one that you have to write. If the question is in terms of sentence, you have to write answers in terms of sentence. If they want you to write in terms of symbols, then you have to write the answer in terms of symbols. Last one, 17E. Ada bunyi kipas-kipas ke apa tu? Zurin. Ada main kipas-kipas macam kat tepi laut pula. Okay, try 17E. Right now, I give you 1 minute. If I have enough money, then I will buy a car and I will buy a house. Actually, the best way to write the sentence is if I have enough money, then I will buy a car and a house. Right? You don't write the same thing. So the converse would be if I will buy a car and a house, then I have enough money. That's the converse. That's why the converse is not necessarily always true. Yeah, but the contrapositive is true. Contrapositive. Converse, this is the implication. The converse is this. And the contrapositive is this. So I said the contrapositive is always true, but the converse is not necessarily always true unless it's the double implication. If I put if and only if, then the converse is always true. All right, go down to number 18. Determine the contrapositive of each implication in exercise 15. So you had to go back to exercise 15 and try to do, what is that? Not 15. Hannah, not 15. Hannah, go down. Tadi sebab numbering is all ni kan is 17 actually. We skip 2 numbers before. Hannah, you take note. Please, you tell Shyam after, yeah? So the contrapositive in exercise 15, but this is actually 17. When we redo the numbering before, maybe memang 15 dah, eh? Okay, so the contrapositive, let me give you the first one and the last one. This is the contrapositive. I will give the first one. If I am the Queen of England, then 2 plus 2 is not equal to 4. Right? It's a not Q implies not P. If I am, not is positive, right? If I am the Queen of England, then 2 plus 2 not equal to 4. Okay, part E. Part E is like this. P P implies Q and R, right? It's part E. If you want to do contrapositive, that will be this, the contrapositive, which is not Q or not R implies not P. Okay, so when you read, you will say, if I will not buy a car, or I will not buy a house, then I will not have enough money. Yeah, you just matching up with the symbols. So sometimes you see, you convert the statement into symbols. Then it's much easier to solve whether you have to do the converse or the contrapositive. Okay, Hannah, next. Okay, write the following statements in terms of PQR. Okay, I just skip that. Go next. 20, just English sentence. Okay, next. Okay, you have to write the truth table and say whether it's a tautology, all true, contingency, all false, absurdity, mix. Okay, you have to write the truth table. Okay. Number 22. Number 22, if P implies Q is false, can you determine the truth value of not P and Q implies Q? Let's think about this. You don't know what is PQ, but you know that is false, right? P implies Q is false. Do you remember? Only time is false is this, right? The only time is false. If P implies Q is false, that's the only way, right? P is true, Q is false. Can you determine the truth value of not P and Q, not P and Q, not P and Q implies Q. So this is not a false, right? P and Q implies Q is false, not false is true, true implies false is actually false. If you rewrite this, is not P or not Q implies. This is what you have to show. Okay. All right. Okay, go down. 23 is, I give an example before for 23. You are given P and Q true, RST false. So try to put in the value. All right. 24, write the negation in good English. Okay, like 24A, write the negation in good English. The weather is bad and I will not go to work. That is P and Q, right? So the negation will be not P or not Q. The weather is not bad or I will go to work. There is no better English than that. Okay, then you can try the rest. Okay, next 25. Converse, contrapositive. Okay, next. Next. Okay, number 26 is starting the proof, right? Proof that the sum of two even numbers is even. We did this for the proof by direct method. Okay, proof that the sum of two even numbers is even. So it's quite straightforward, right? Proof that the sum of two even numbers is even. Okay, so that is to show if x is even and y is even, then x plus y is even. Easy, right? When you write it in terms of symbol. Okay, so assume x and y is even. Assume x and y are even. Then x is 2k1 and y is 2k2, right? Thus, x plus y. If you want to see me bigger, you can move the sharing to the left and make my side bigger. Then you can see me bigger. So this is 2k1 plus 2k2 is 2k1 plus k2, which is 2, call it m, right? So thus x plus y is even. So the sum is even. It's quite straightforward, right? The same thing for odd, not same, but the sum of two odd numbers is even. Don't put odd. So you put this is odd, this is odd. When you add 2k1 plus 1, 2k2 plus 1, it's 2k1 plus k2 plus 1. 2k1 plus k2 plus 1 in parentheses, so 2m, right? So it's also even. Even you add two odd numbers, it's also even. All right. I did 28 somehow. You had to show by contrapositive for 28. Okay, you cannot show by direct method. Contrapositive or by counter, what? Not counter example, by contradiction. Yeah, number 28. Okay. 29. Prove or disapprove n squared plus 41n plus 41 is a prime number for every integer n. For number 29, if you plug in numbers, you can get the answer to be not prime, then it's true, it's disapproved, that it is not always a prime number. So this is the proof by counterexample. Counterexample, as I mentioned earlier, you choose one that is not true, that is not true for all. Yeah. All right. Go down. 30, 31. 31 is very similar to the one that I showed you earlier today for mathematical induction. Number 31. Okay. So when n is 1, you get 1 times 2 is 2, right? If you don't want to just do P1, you want to do P2, you want to try and see P2. So P2 is 2 plus 4, 6, meaning 2 term, right? P2, and the right side, 2 times 3 is 6. Okay, so you can try number 31. For number 32, when n is 1, is easy, right? 1 left, the right one. Number 32, when n is 1, it's not true, right? The left one becomes, the left one, you see this? Let me see. Sometimes I'm afraid of the typo we make. We want to show 1 plus, oh, there's a typo, yeah? 1 plus 2 to the 1. This is 2 to the 0. Plus 2 squared plus 2 cubed. Hannah, you help me. Okay. Hannah pun tak dengar suara je hari ni. I don't know if you
Ada Prof.
cakap seorang-seorang ke apa pun tak tahu eh. Okay. So typo this is 2 squared. Okay. I'm checking now. When k is 1, when n is 1, when n is 1 here, I get 1 plus 1 is 2, is 3, right? But when n is 1, I get 1. So what happened? What if I have like this? When n is 1, okay, when n is 1, I get 1. When n is 2, 1 plus 2 is 3. Okay, when n is 2, 3, 4 minus 1. When n is 3, 7, right? When n is 3 is 7. 8 minus 1, 4, 7. I think that's a typo there. Okay, can you please edit that? Okay, 2 to the n minus 1. So you can show it's true for 1, show it's true for k, assume true for k. I think it's quite straightforward. You just put 2 plus k, and then this is 2 to the k minus 1 plus 2 to the k, right? And then you get 2 to the k plus 1 minus 1. I think it's straightforward for this. Okay, for next, I have 1 more minute. Okay, next question. Number 32. Number 32. It's very similar. That's this. Okay, 33. Yeah, 33. Oh, okay. This one is actually the factor, right? Originally. But when you put n equals 1, you get 1. That's true, right? When you put n equals 2, you get a plus 1. Okay, so you can try this. Number 34 is very similar to the one I show, but this is with the cube. Okay, show with the cube. Number 35 also is very similar to the one I showed earlier in the example, in which you have to prove. If you cannot prove it from the left, you prove it from the right. Okay, it's similar example, right? Why it look very similar to the 1, 3, 1 plus 2 to the n. Sama lah. Okay, Hannah, 35 should be removed from the exercise because I put it in example. Okay, next. Okay, all right. Number 37, find the least n for which the statement is true. So you can try when n is 1. When n is 1, 10 less than 3, no. When n is 2, 20 less than 9, no. When n is 3, 30 less than 27, no. When n is 4, 40 less than 81, yes. So the least n would be 4. So you can try 1 and 1 and 1, yeah, for 37. You plug in 1, no. You plug in 2, no. You plug in 3, no. You plug in 4, yes. So 4 is the answer. All right. The rest, why is it there? Go down. That is just for the set. Oh, that one is next. Okay. So you can stop sharing. So I guess this is it for today.